I'll be right with you, gentlemen.
Morgan Freeman has played God in the movies, but I
See, it's doing that thing again. Oh, never mind. It looks like it's working. Okay. All right, gentlemen. So congratulations. This is it. This is our last, this is the last time I'm going to take attendance. So this is the last time that you're obligated to, you're expected to show up. I just want to say I'm proud of everybody. It's not easy. This is not it's not an easy thing to do. You have to be self-motivated to navigate this realm of like remote learning, this whole thing of it being remote. Hang on. And so you're here, right? You did it. So just go ahead and do what you need to do to finish. So today is the last day that I'm taking attendance. So tomorrow, this is the last official day of class. So Thursday and Friday is the reading period. So you shouldn't be meeting in any of your courses. Your final exam should become available this upcoming Sunday at 11:11 a.m. and is due the following Friday at 11:59 p.m. And then so during the week of finals, I probably will come on the Zoom call during class time on Monday and Wednesday just to make myself available. I'll probably be gaming or something, but if you need to reach me, I'll be there. My intent is to be there. And so the thought process for today, I was thinking that we could go through the last review exam 3, right? Because I think we did exam 1 and exam 2. So let's take some time to go through and draw out as many concepts from exam 3 as we can. Okay, and as always, if you have questions about anything, feel free to unmute yourself to get my attention and we can talk about it. Okay, so let's hop over here. Okay, let me check one more time because I know we got people. Okay. Yeah, I can't think of anything else. And this upcoming Friday, that Friday, the 9th, not this week, but next Friday, a week from this Friday, is the hard deadline for all assignments. So not only is the final exam due at that time, but everything on Pearson is going to lock out a week from this Friday. Okay, so this is the home stretch. Okay, so exam 3 comes from chapter 2, right? There are a couple of sections after this, so maybe we might be able to get to them. Identify the graph of the following quadratic, right? Okay, it looks like we can do transformations, right? The base function is a quadratic, is a U-shaped curve. That +1 tells us, the +1 on the inside tells us to move left by 1. The 2 on the outside tells us to do a vertical stretch by a factor of 2 and then flip vertically. So it should be kind of narrow to the left by 1 and upside down. And I think the only one that does that is A. All right, so I'm just going to go with that. Okay. Find a quadratic function of this form that passes through this point. All right. Okay, so for instance, when x is -3, -3 squared is what, 9? -27 divided by 9 is -3. So that means that A is -3. So then it should just be, turn this thing off. -3, come on. -3x squared. So that way, when x is -3, the output is -27. Okay, I'm going to go on to the next one. I just plugged in the x and the y and solved for A. That's all I did there. Find a quadratic function whose graph has this vertex and passes through that point and write it in standard form. Okay, let's take some notes on this one. So let me get a copy from about here. That's good. Copy and delete. And I can just paste. Awesome. All right. Ooh, good talker. All right. So find the quadratic. So standard form of a quadratic. If you have a formula sheet, you can add this, the standard form of a quadratic. I'll do it in green. So I'm gonna say the standard form of a quadratic. That's for quad. Let me see. There should be, you can do it as f of x equals a times x minus h squared plus k. Because in this form, it gives you the coordinates of the vertex. It tells you a lot, and you can actually graph the quadratic using transformations when it's in this form, right? So they give us the vertex, they give us the h and k, and they also give us an additional point. So let's plug in the information that they gave us. Okay, so the vertex, so in other words, this is our h, this is our k, this is our x, and this is our y. Okay, so we don't have any information on a. X is -1, h is -5. Notice my use of parentheses. Our k is 4, and our y is 0. Okay, so at this point, we have one equation, one unknown, so we can solve. 5 minus 1 is 4, squared is 16, so that's going to be 16a equals -4. So then a equals a -1/4. Okay. Okay. So then our function should take on the form -1/4. H is -5, so you can write that as x plus 5 squared plus 4. Okay. X plus 5 plus 4. -1/4 times x plus 5 squared plus 4. Okay, I think that's it. So you can clearly see your vertex is -5, 4. And then it's also a good idea to confirm that these points work. When x is -5, the output is 4. When x is -1, 4 squared is 16 divided by 4, output is 0, right? I'll check Zoom again at about a 15-minute mark in about a little over 2 minutes, okay? Let's go on to the next question. Graph the given function by writing it in standard form, which is the y equals a times x minus h squared plus k. That's what we just had before. And then using transformations on the basic function of x squared, then we're asked to find the vertex, the axis of symmetry, and the x and y intercepts. Okay. So rewrite this in standard form. So to go from the general form of a quadratic to the standard form, we're really supposed to use completing the square. I think we do b/2 squared plus or minus. All right. So I'll take some notes here. But this is, again, completing the square. We would have x squared plus 2x. So it's going to be, basically what we're doing is plus 1 minus 1. So when you do your b/2 squared and plus or minus, so our b in this case is 2. 2 divided by 2 is 1. 1 squared is 1. So we're adding 0 in the form of plus 1 minus 1. So we're not really changing the outcome. We're just going to change the form. Now, if we group the first 3 together, they can be factored, right? It looks like the first 3 can factor into x plus 1 quantity squared, right? That's the whole point of completing the square, so you can get it into this form. And then the second part just persists, okay? And then if you just want to be sure, you would FOIL, expand it, and you should get back to the original, right? So quick demo on completing the square. It would be what? X squared plus 2x plus 1 minus 1. Yeah, I think we're good. Okay, type an equation. So we need our y equals, otherwise it's gonna mark it as wrong. To graph the given function now. So now that we have it in standard form, we can graph a parabola using transformations. So we're starting with the base function of x squared. It says to go 1 unit to the left. So I'm gonna say 1 unit, oh come on, right here, 1 unit left, okay, and then 1 unit down. I think it gives me a hard time because I'm on the Apple device. Down, okay. So then to graph, so a parabola tool is over here on the right. I'm just clicking on the origin. We said what, 1 unit left, so horizontal shift. Oh, I can't see it. Usually, there it is. Okay. Yeah. See, that's what I needed to see. 1 unit left, and I think it was 1 unit down. Okay, and I think that was it. Hit save. The vertex. So in this standard form, the vertex is -1, -1. It's the h comma k, so it's -1, -1. The axis of symmetry is the x coordinate of the vertex, so that's going to be x equals -1. Okay. X-intercepts. So if you set y to 0, if you set this to 0 and solve, you get a 1, square root is 1, 0. So it's just the origin. Wait a minute. From there, it looks like it's 0 and -2. You get 1. When you take the square root, you get plus or minus 1. Yeah, so you get -2 and 0. So then -2 and 0. The y-intercept is the origin, so y equals 0. Okay, I think that's it. Okay, let me check on you guys in Zoom. Okay. So shameless plug, not last night, but night before last on the Daily Show, they interviewed Will Smith. I thought it was a fantastic interview, and like I was curious to see how is he going to navigate that realm of the slap at the Oscars. Trevor Noah is a professional. He did a great job. Okay, is it frozen? Why does it do this? Okay, I think we're okay. Okay, yeah, but he just does a really good job. Like I don't know that I could do it. Because I felt like I would have pissed him off or would have said something like, "Yo, how you go treat bro like that?" But what Will said, it was a good interview. It's a shameless marketing for them, but I think it was a really good interview. It's worth watching. Because at the end of it, it was just really good, and I would encourage you to watch it. But then the episode before that, he interviewed President Obama, so that was interesting as well. The interviews are really interesting. He has some of them are really moving. Okay. So this question, it says, graph the function by writing it in the standard form and then using transformations to find the vertex. Same kind of deal, right? This one looks totally involved. I don't feel like doing it, but I think we need to write this one out. We want to transform it into standard form. So they're asking us to basically do completing the square. I'm going to write this one out though. Okay, that looks good. This was a little bit more involved, but we're gonna give it a go. Okay. Copy and delete. Awesome. All right. Let's see, graph the given function. Okay, so let's write this in standard form, right? So this one's a little bit more involved, and a more involved example on completing a square. So the first thing with completing a square is that the leading coefficient needs to be a 1, right? 14, 15, right? So we can factor out 3. Let's factor out, let me think about this for a second. Yeah, let's just factor out 3 from all the terms, right? So if we're starting with 3x squared minus 30x plus 78, okay? Now, if we factor out 3 from every term, then that's going to leave us with x squared, what is that, minus 10x. There's a 2, 18 is what, 6? 60 plus 18, okay. We get this. So then completing the square, again, we're adding 0 in the form of plus or minus b over 2 squared, all right? So, and we got to keep track of like our grouping and everything like that, okay? So we're going to say plus b over 2 squared and minus b over 2 squared, okay? So our b in this case is the negative 10, so we're going to say negative 10 over 2 squared and minus negative 10 over 2 squared, okay? And then the 26 persists, and just stay aware of your grouping, right? How we have our grouping going, okay? Negative 10 divided by 2 is negative 5, squared is 25. So in reality, we're saying plus 25 and minus 25. Okay, 26 persists. Now we can start to simplify some stuff. Okay, so let's do this. Okay, so if we focus on the first 3 terms, that factors, right? If we group those first 3 terms to the left of the green bar, it factors into an x minus 5 squared. Okay, so the 3 persists. It becomes x minus 5 quantity squared. Okay, keep in mind we're still working here. Negative 25 plus 26 is what? Plus 1. Okay, and then one more step. Let's distribute that 3 properly. I'm going to get 3 parentheses x minus 5 squared plus 3. Okay, this part is easy to lose track. If we didn't have our grouping, if we weren't aware that we needed to multiply those 2 expressions by 3, it's very easy to miss that. Okay. All right. All right. So we got this 3 times x minus 5 squared plus 3. Okay. So we got y equals 3 times x minus 5 quantity squared plus 3. X minus 5. Yeah, looks good, right? Okay. Again, we could check if we FOIL and simplify, we should get back to the original. X squared minus 10x plus 25. You get your negative 30, negative 75. Actually, plus 75 plus 3, right? So if you FOIL it out, you get back to the original so we can be confident in this. Okay, and then to graph, now I would like to keep my standard form. That's what's going to make graphing easier for me. Okay, I'm going to hit my parabola tool and I'm going to click on the origin. Okay, so now let's try to capture our transformations. We have a total of 3 transformations. Again, the recommendation is when we're working transformations is to work our way from the inside to the out. Okay, so the innermost transformation is that minus 5. That tells us to go to the right by 5. So we're going to drag this to 5. Okay, we did a vertical stretch by a factor of 3. Okay, because that 3 is on the outside. We multiply by 3 on the outside. And then we added 3. So that's a vertical shift up 3. Okay, and that's it. Let's close this out. That looks good. Let's hit save. The vertex is at 5, 3. Axis of symmetry is going to be the x coordinate of the vertex, which is x equals 5. X equals 5. Okay. X-intercept. Okay, you can look at the graph. Notice, so we had a U-shaped curve. We went to the right and then we went up. So, and we didn't flip or anything like that. We didn't stretch. So it doesn't cross the x-axis. So there are no x-intercepts. But then the y-intercept, if you said x0 is going to be 78. The y-intercept is going to be y equals 78. Right? Because if you said x is 0 in the original, you should get 78. Okay. Let's go on to the next one. Ooh, let's see. Thank you. I'm so tired of doing these. But I guess that's what this was about. So let's just try to knock it out. For this equation, determine, okay, so it asks us to determine whether it opens up or down, right? So if we look at the leading coefficient, the leading coefficient here is a 1. It's positive. That tells us it opens upward, okay? The vertex, okay, so there's a formula you could jump straight to the vertex. The vertex formula is H equals, I think it's negative B over 2A. I think that's right. Nah, probably, I think it's negative B over 2A. Let me do a quick search just to confirm. I'm gonna go with it. I'm confident in it. The vertex of the parabola, so if we did negative B over 2A, that's going to be 10 over 2, which is 5. So that's the x coordinate, all right? So the x coordinate is 5. So then we take that and pass it through the function. 25 minus 50 is negative 25, plus 9 is negative 16. Okay, so this should be the coordinates of the vertex. So the axis of symmetry is x equals 5. 5. X-intercepts, if we set y to 0, we probably should write this out. We are asked the graph. I guess we need to write it in standard form. Let me see. If you said b over 2 squared, 5, so plus or minus 25. Okay. So that would be x minus 5 squared minus 16, right? Yeah. Okay. Let me do this real quick. Can I write it somewhere? Okay. I'm just being lazy. I should write this out. So if we do, I'm just thinking about it in standard form. X minus 5 squared minus 16. Okay. Yeah, let me just write it out. Or we could use the quadratic formula, but we still have to write it out. Let's just write it out. X squared minus 10x plus 9. X squared minus 10x plus 9. X squared minus 10x plus 9, okay? Okay. So if we did complete in a square, we're gonna have x squared minus 10x. Our b we're gonna say plus negative 10 over 2 squared and minus negative 10 over 2 squared, and then the plus 9. Okay. So then that's gonna be this. Negative 5 squared so it's basically plus 25 and minus 25. Okay. Factor by grouping. The whole point is so that we can group those first 3 together. That factors into x minus 5 squared. And that's negative 16, right? Mm-hmm. Okay. So then this tells us it's basically a parabola. It's a U-shaped curve that went right 5 and down 16. So then if we want the x-intercepts, if we set this equal to 0 and solve, so let me highlight this just for my reference. So again, if we set this equal to 0 and solve, we add our 16, okay, square root, and we get plus or minus 4, and then add 5. So then x is going to be, what is that, 1 or 9? Okay. That's why I wrote it out, because I was trying to get to the x-intercept, and trying to do this in here was not a good one. So I was like, let me just write it out. So the x-intercepts, and again, hopefully we haven't made any mistakes. 1 and 9, right? So what we're saying is that when we pass either when x is 1 or when x is 9, the corresponding y should be 0, right? 1 minus 10 is negative 9, which is 0. 81 minus 90, let's just try that again. Yeah, 81 minus 90 is negative 9, which adds to 0, right? So both of these produce a 0. And then the y-intercept of x is 0 is going to be 9, right? Oftentimes the y-intercept is a lot easier than the x-intercept. It's supposed to be 9. What time is it? Let me check on you guys in Zoom. All right. So then we said what? We went, it's the vertex. We went right 5 and down 16. That's it. We just went right 5 and down 16. So U-shaped curve. I'm just clicking anywhere. And okay, right 5. I could edit, I could just type it, but I'm just dragging. Down 16. Okay. And then we just need one other point. We said that when what was that 1, 9? Vertex. Oh, this thing is being totally temperamental. Come on. It might be because sometimes when I have it plugged in while I work, it messes up. Okay, let me hit save for right now. X-intercepts. So we can use that 1, 0, right? Let me edit this. 1, 0. It's different. Okay, I think that's it. Okay, I'm gonna hit next. Let me see the time. Man, I'm so tired of doing these. For this equation, parts A through E, okay, does it open upward or downward, right? So the leading coefficient out, this one you have to rearrange it, right? It's out of order. So with these, it's a good idea. It's always a good idea to put them in descending power order. So the highest power here is squared. So that means the leading coefficient is actually -1. So that means that the parabola opens downward because A is negative. So that's A. The vertex is negative B over 2A. So that's 4 divided by 6. Oh, no. Negative B, right? So 4 divided by -2. So that's what? 4 divided by -2 is -2. Okay. That's the x coordinate. Then we basically pass that through the function to find the y coordinate. So that's going to be a -4 plus 8 is 4 plus 3 is 7. Okay. Hey Siri, what's 3 minus 4 times -2 minus -2 times -2?
3 minus 4 times -2 minus -2 times -2 is 7.
7. Okay, just making sure. And then the axis of symmetry is the x coordinate of the vertex. So that's going to be x equals -2. I feel like I got some of these wrong. But I'm just kind of going through these. Okay, if we set this equal to 0 and solve, I guess it wouldn't hurt to do the quadratic formula here. We've done several examples with completing the square. Let's do an example using the quadratic formula, if I can get this to behave. We might have time for 1 or 2 more after this. Come on. Okay. Copy and delete. Paste. So, all right, so quadratic formula. The way I remember quadratic formula is as follows. I got this from a student. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. Let's do that one more time. The negative boy couldn't decide to go to the radical house because he was square, so he missed out on 4 awesome chicks, and it was all over by 2 a.m. Okay. So then with the example that we're working, again, the recommendation is to put it in descending power order. So then we're going to have y equals negative x squared minus 4x plus 3. Okay. So then we can see that our A is -1, our B is -4, and our C is 3. Okay. So then x is going to be equal to -4 plus or minus the square root of -4 squared minus 4 times our A times our C. Okay. All over 2a. 2 times -4. Okay. So then this is going to be 4 plus or minus, that's going to be 16. 4 times 3 is 12. -2. 26, 28. 7 and 4. So that's going to be 4 plus or minus 2 root 7 over -2. And that's going to be -2 plus or minus square root of 7. Okay. -2 plus or minus the square root of 7. But I feel like we made a mistake. Let's go with it. Using radicals as needed. Okay, when you see that, that's a good omen. -2 minus the square root of 7, comma, -2 plus the square root of 7. Okay. And then for the y-intercept, if we set x to 0, we'll get 3. Okay. And that's about the best we can do there. We need our standard form. Oh, we didn't write it. It looks like it's upside down. Let me scroll up to the vertex portion. X-intercepts, axis of symmetry, -2, 7. Okay. -2, 7. Okay. So -2, 7. So we have our U-shaped curve. -2, 7 is here. Okay. And then we had a y-intercept is 3. So I'm gonna click there. Oh, okay. Well, we can use the axis of symmetry to, so if we go 2 to the right, we're at 3. That means also when we go 2 to the left, we should also be at 3. So right here. Okay. I'm just going to go with it. What's the time? Okay, I think I'm going to go ahead and let that be it. Let me hit next. So we got through about 7 questions. Let's see, submit. Okay, let's see how did we do. Seven, right? I think we got them. We did pretty good. Okay, guys. All right. So with that, that brings us to the end of College Algebra 1. All right, this remote session. Hopefully you learned something about yourself, okay? And hopefully you were able to position yourself for success. So the only thing that you're responsible for now is the final exam. Again, that'll become available this upcoming Sunday at 11 a.m. It'll be due the following Friday at 11:59 p.m. All right, guys, I'm proud of you. I do plan on being on the call next week on Monday and Wednesday, just to be available. So you can, if you have questions or anything. Otherwise, guys, I'm proud of you. Good luck with everything. I'm here if you need help or support. Take care. And from one beautiful mind to another, take care. Peace.
Thank you, Dr. Pfeiffer.
Yep.